This video is to give you some help on how to work on your project. Unlike some of the other videos, this is a lot less rehearsed and I don't have quite as many notes for myself. So it will be a little more genuine, so you can see more or less how it should feel to work on your project. That being said, I have made some notes because I don't want it to take forever. And I will be recreating some of the steps on the screen so you can see what it looks like. So you pick whichever software you want that we worked on in class, of course not including StatCrunch. I'm going to be using R, and I think I'll make probably a second video on R Markdown and to show you how the stages fit together. So in the first stage of the project you're looking for data, and I'll pretend like I'm looking for data. I'm going to pick a bad data set, but it's marginally good. It's good enough to do this demo for you, and then I can give you some explanation as to why the student would get some credit and why they would get docked some credit. So for the purposes of explaining what you're trying to do in the project, it's a good data set, but as a selection for a data set, it's a poor choice. Okay, so now I'm going to go to our usual website, but not the to-do list. I'm going to go back to the main landing page, and I want to look for a data set. I'm sorry, wrong link. Data sets. Okay, so my suggestion, if you haven't gotten a data set yet, is go here first to this page I just clicked on, because it does a lot of the pre-analysis for you. Now these packages, or these sets of data, are theoretically all available from inside R, although some of them I have trouble getting them to summon. So you may as well just download and upload, but if you figure out how to get them to automatically load in R, that's fine, you can do that. But the point is they're CSV files, so you can load them into any software you want. You're not bound to stay in R. I'm going to pick this Beaver set. It is Beaver body temperature data. And it's a pretty weak data set. If you want to look at it, I'll show you why. Actually, I have to save it because I don't have it on this computer. And so I'm going to open it and show you why it has strengths and weaknesses. So this data set, it's measuring the body temperature of the beaver, single beaver. So I don't know, they must have like put a probe in the beaver or something. And 0 and 1 tells whether the beaver is active or not. They are nocturnal creatures. So during the course of the temperatures data collection, the beaver became active. And you can see by looking at the clock that this is midnight in row 89, and every 10 minutes there's a temperature reading. So you can see that. And the day goes from 3:07 to 3:08. So there's really only 2 days, and it's just over midnight. So it's less than a day's worth of collection. And so the reason why this is a little weak is because this day column isn't actually meaningful. It tells you there's 2 days, but really there's 1 day. So that's an insight you have to figure out. Time, we're going to have to manage this. The time is given, they just concatenate the hour and the minute, and that's going to make for messy numbers because there's going to be a big gap between, let's say, after 590 to 1000, that's just a 10-minute gap. So we're going to have to fix that. So that's a problem, but it's a small problem because we can fix it. Temperature is good, activity is good, but I was actually hoping that you guys would get data sets. You should look for data sets that have more than one binary or categorical variable. So active is good, that's a good variable, but there should be another categorical or binary variable that you can compare them against each other. And so for example, I'm going to use day, which is completely wrong because as I told you, there's really only 1 day's worth of data. It wraps around the next after midnight, and as far as the beaver is concerned, it's 1 day. So we don't have 2 days worth of data. But I'm going to pretend we do just so that I can crunch out a chi-squared, and that will be a weakness in the presentation because if the student didn't notice that that was an inappropriate analysis, then the student would get docked points. And you may say, oh no, how will I know if I'm making an inappropriate analysis? Well, that's why you're supposed to check in with me and show me your preliminary results so that I can give you corrective feedback before your eyeballs deep in writing up your results. That's why. Okay, so we have really only one categorical variable, and we have two otherwise numeric floating point type variables. And so that's why it's weak, but it's good enough for this demonstration so that I can show you some of the neat things you can do. And furthermore, I wanted to pick a data set that you aren't allowed to pick. So if I picked a good data set, that would be one less data set for you to pick from. Here you go. All right, now I will begin the analysis of this data set because I've now got it loaded onto my desktop. I'm going to attempt to run R or RStudio on my computer. Hopefully this will work. Maybe that's the wrong command to start R, so I'm going to try another one. That works. Okay. So it will look a little different on my screen than it looks on yours. You are going to probably be doing this through RStudio, and I can do another video on that later. And I'll do that from my other computer so you can see it. All right. Now, if you're working on this project, if you're in RStudio, you can use the GUI to import the data set, and I encourage you to use reader R or read R rather than read base, because I've had trouble with read base, but it doesn't really matter. Whatever you use, whatever works, you read in the data set. And the other thing you want to do is you want to have available a copy of the homework. So make another copy of yourself for yourself. And I'll show you. In this case, I am using R, so I'm going to dig down into here. I think homework 4 was R. And so this is the file I'm looking at as I'm talking to you. I have a printout of this, and I've marked it up just for this project. So I'm going to keep this off to the side because I don't know how else to show it to you. What else do I want? Oh, I have a piece of paper, whole bunches of pieces of paper, and so I'm going to have external open so I can show you the kinds of things I might write down for myself on this piece of paper. So I have these three things. I have R open, I have some paper, and I have the old homework, a new fresh copy, so I can annotate it to my heart's content. Now I have to read in my data, and I'm going to try this. It should be easier for you if you're using RStudio, but I'm here at the command line. I'm going to try to do it this way, and hopefully it knows where the beaver is, and it doesn't. So you know what, I'm just going to move over to wherever the beaver is because it's easier than trying to figure out how to go there inside R. And I'm going to try that again. Beaver is read CSV, beaver CSV. There we go. And there's my beaver data. Great. So again, you're going to read it in differently, but I've just read it in. Okay, the next thing I want to do is I want to take a look at what the variables are that are inside this file. Okay, so in my case, I'm going to look at my data, and I'm going to see. So R does something a little bit silly. The first column of data is just the numbers, and I already have just the numbers. So it gives me another column of X, which is completely useless. I'm just going to ignore that. But I have day, temp, time, and activity. Well, what does that mean? So the beauty of this particular page of data is that over here there's a doc file, but they're going to show you as HTML. It's going to tell you exactly what all that means, and you need all this information for your write-up. You don't need all this information today for your initial analysis, but you should not forget where it is, because you're going to need to reference all this stuff that I've highlighted. You want to reference the web page you got it from. All that stuff is going to go in your write-up. In fact, all this information is going to fit. The whole information in this whole doc file is going to end up in your write-up. So you know the day is really only one day, even though there's 2 days. And the time we're going to mess with, the temperature is what it is. Activity is just 1 means the beaver is outside the retreat and therefore engaged in high intensity activity. 0 means the beaver is inside the retreat. And that much you need to know, or you can't do the analysis. So on my page, I will write for myself, day is useless, so the time goes from 9:30 to 23:50, and it goes from 0 to 200. So it goes to 2 o'clock. We're going to mess with that. Activity is just going to be 0 or 1, not active, and active. And what else do we need? We need the day, not really. So unfortunately, we only know whether the beaver is active or not. Oh, we have the temperature. Temp in centigrade. So we really only have 3 useful columns of data. But that's what we have to work with. Okay? So I have this on this piece of paper to remind me what's happening in the beaver data set. I go back to R and I say, now what do I want to do? So as I'm looking through, I say, well, the project says I need to have 7 presentation points. I need 7 pieces of analysis of some sort. And one of them should be ANOVA chi-squared or you know, some kind of scatter plot with a best fit line. One of those 3 things should show up in the presentation, if at all possible. And again, there are exceptions. Sometimes it doesn't have to happen. But let's aim for one of those. So I look and I say, well, what about chi-squared? And I'm going to show you chi-squared even though it's completely ridiculous because, as I told you, we really only have 1 day. But just for the sake of showing you how to do a chi-squared again, I'm going to pretend like there's 2 days worth of data, okay? So I'm looking here and I say, haha, how do I do chi-squared? Look and look and look and look, and I say, aha. Now it's possible that I need to do some imports, but I'm going to just try this. It turns out I won't need to do imports, but some of these commands require imports. And so we can go ahead and try them, and if they don't work, we can go back and try to do our imports if we need to. So here I am looking at chi-squared, and I say to myself, want chi-squared of day versus active. That's what I tell myself. Alright, so now I'm going to try to figure out how to make that happen. Okay, so it's beaver. So I know that in my homework I called it new table when I created this. I'm going to use new table. Is table of what? And I'm going to write down on my paper, I'm going to say, I think I want to do it this way. I think I want to say new table is table of, and it's going to be beaver because it's not the same thing I used in the homework. It's going to be beaver $day versus beaver $active. Why am I putting the active second? Well, it doesn't actually matter, but I'm sort of following the same idea. Whatever I thought was going on here, I try to carry over that logic from the homework sheet onto my little scratch pad to figure out what I want to do in R. So I scratch it out on paper first, and then I go ahead and type that in. And see what happens. Nothing happens. Well, it wasn't supposed to. This is just the tabling process. And as you can see, the beaver is when the beaver is active, it is partly in day 307 and partly in day 308, but the beaver is never inactive in day 308 because we cut off the data. We did not collect data throughout day 308, only after midnight when the beaver was out and awake at night. Okay, so again, this is really, really stupid analysis. It's so stupid that the computer is going to yell at us when we try to do the analysis. That's how stupid it is. So let's go ahead and try to do this. See, it warned us. It said chi-square approximation may be incorrect. Well, yeah, no kidding. So it's telling me I have a really significant p-value, and if the student is doing this work and says, hey, the beavers were really active one day and not the next day, or whatever, I'm going to say, look, you didn't even look at the warning on the computer, and furthermore, you didn't notice that this was a really inappropriate analysis. And if you didn't do the check-ins with me properly, I won't feel sorry for you. But if you're doing the check-ins with me, I'll tell you, hey, guess what? There's a reason why that happened. Right? So that's why you want to do the check-ins. All right. But let's pretend like it was a reasonable analysis and continue with the discussion. CHSQ of expected. So we see our observed and our expected, and if it's already rounded the way we want, but if we had a whole bunch of digits way out here and we wanted to truncate them, you'd use this round command. We don't need to do that today. Okay, so we've got all our chi-squared. So we've got credit for having done a higher level analysis. Well, what's the other higher level analysis we might be interested in? How about ANOVA? Can we do ANOVA on this data? That's actually a little more reasonable because we have enough data that we have the animal is partly active and partly not active, and we record the temperature of the animal when it's active and when it's not active. So what we're going to ask is for chi-squared, what we need. Okay, so I'm going to put down on my list, okay, yay, 1, and then it's a high level analysis. We did a chi-square, we're going to do another one, we're going to do ANOVA, AOV, and we're going to find out, oh, it's right here. So you're going to say AOV, so results is AOV of what? So in the other one we put exposure, which was our numerical data, our floating point data, and the tilde, and then gender, which is our binary variable. So why don't we say instead of exposure we want temp, and we want tilde, and we want active. Okay, then what do we want? And then we're going to say data equals beaver. Sorry it's so sloppy on my computer here. Okay, and then we're going to do summary results and see what else we can do. Okay, so R, but I'm going to say results because I think R might be used for something. I'm not sure, just want to be careful. And then I'm going to go ahead and say temp tilde active data equals beaver, nothing shows up. Good. Summary of results, yay, it's telling me, this 3 stars here is telling me that I have a very significant result. In fact, this is why this less than 2 times e to the negative 16th is super significant. So it's saying that we have enough data to conclude that the temperature of the beaver is significantly different when they are active versus when they are not active. Okay, so what about Tukey? This is really stupid. Why is it stupid? It is insanely stupid because we only have 2 categories in our categorical variable. That's why it's binary. We have active and non-active. And so, okay, yeah, I spelled it correctly. It's stupid. It's just stupid. So this is why the computer is yelling at me, because I'm trying to do a Tukey analysis on something and I only have binary. And so we don't need to go beyond ANOVA, because ANOVA for 2 things like that is just, that's it. You don't have to do any further analysis with that. It's either 2 things are either different or they're not. But if you have 3 or more things, then you want the Tukey analysis to figure out which ones are different. Okay, so good. So I'm going to mark down on my sheet that I'm keeping track of my analysis. Yay, this is a high level tool, and so we're going to try, well, let's try for all of them. Can we do a scatter plot? Actually, and so I'm going to do something different with this because the data is split by time. I'm just going to color code the dots to tell when the beaver was active and when the beaver was not active, and that way I'll put it on the same time versus temperature plot. And so it's going to be time over here, temperature versus here, and it's going to be, you know, 2 different colors, like 1 color over here and 1 color over here. So I can tell when the activity level changed. And that will be a nice tool to use. Okay, so I'm going to go ahead and try to build this thing. But I'm going to have trouble because notice that the beaver, this is a small data set, I can throw it all up on the screen at the same time. Notice that the time is a mess, right? We talked about that. So I'm going to create and mess with this data in such a way that I'm going to, you know what, at this point I'm going to actually just show you the file I used, and I'm going to minimize this to save time, but I'm going to talk you through the file, and then I'm just going to cut and paste from my other file. Okay, so bear with me while I find it. I have my beaver script here. And I'm just opening it in Emacs. I don't even have to open it at R. It's just a text file. Okay, so I have made a new variable called beaver hour, which is just the floor of beaver time divided by 100. So I had to go figure out how to do that. I guessed and I got it right, but I had to look up how to do modular arithmetic in R. And so I found out that if I use a double percent, I got modular arithmetic in R. So I didn't know that, but I had to Google that. And now that's easy. I can make a new variable called beaver real time. And then I got rid of the gaps. Now I feel comfortable using the time. Oh, but there's one more problem. I'll go ahead and plot it this way and then show you what the problem is. So what if I plot beaver real time versus beaver temp? Let's see that. So the problem is, notice over here, all these temperatures really should be over, well, you can't, over here. They should be glued on over here. Because this is the start of a new day, so it's really misleading to put them at the beginning of a plot when they really belong at the end of the plot. So we had this issue here. But it's really easy because if you look at the data, it's just everything, well, here, what does the data look like now? Okay, so we have this thing called real time. And everything over here is smaller than a certain value. I'm just going to say less than 5, but it's less than other things too. As long as it's something that's less than even 9, it'll work. Okay, so like everything from here to here, I'm going to add 24 to it. And then it will automatically be glued onto the end of the other data properly as it should be. So we're going to, or we could even just say every time day is 308, add 24. That would work too. So I'm going to just adjust this. I'm going to do this little for loop. I'm going to dump it in here. And see if it fixed the problem. Yes, it fixed the problem. Now I'm going to up arrow and do my plot again. And this completely fixes the problem. The plot looks much nicer now that I've glued all the dots together. Again, if a student did that, I will be happy. If the student fixed the gaps between the hours and glued the data correctly together, even if they had a bad data set or otherwise did poor analysis, I will look favorably upon the fact that they at least figured that much out. So that's not totally what I want my plot to look like, because I really want it to be color-coded. And so again, I messed around with this for a while, and if I just color-coded it by activity, the problem is the computer interprets 0 and 1 to be black and white, and I didn't want to do that. Or for whatever reason, it made the dots disappear. And so I found out that by just adding 1 to the activity level, I got a reasonable color scheme. That's okay by me, as long as they're 2 visible colors. And so down here in the beginning set of the data, you can see the beaver is starting to wake up in the evening. And then there's a gap because we are only taking the temperature readings every 10 minutes. And then it jumps up, and then we have higher temperature upon first waking, and then it's sort of sliding down over the course of the evening. Not really sure why. I don't know what the beaver was doing. Maybe the beaver went out and had breakfast and then decided to sit down for a while. No clue. I have no idea what the beaver's doing. But that's a much better plot than what we started with. And you would put your graphics, and you put some kind, you can use other software to put little boxes in there, or you can put what do you call it? You know, that little key in here that says, you know, 0 equals active, red 0 equals active beaver, black 0 equals inactive beaver. And you could Google how to do that, or you can ask me for help with that. The whole point of doing the check-in with me is so that you can show me what you have and tell me what you want to do next. Ask me questions like, how do I do such and such? And then I'll help you. Okay, so you're looking at your list that you have. You've got that. You've got 3 things. You're supposed to have a total of 7, so we want 4 more tools. So you want 4, 5, 6, 7. We're still looking for 7 more things for a nice presentation. Okay, we need a box plot. We had ANOVA. We never did box plot with our ANOVA. So let's do that. Box plot of beaver temp. And then you use a tilde when you're using box plots. Beaver active. Okay, not bad. And again, this is really not good for a presentation, but it's really good for check-in data. To check in with me on your graphics and results, you can verbally tell me, hey, the 0 is an inactive beaver, the 1 is an active beaver. You can see the temperatures are different. And then we talk about how to recode those variables. We talk about, hey, we should recode those and make that graphic look really nice. So it's really, really easy to understand. And notice these 2 points here. The beaver is actually transitioning to being active. So if you remember on the previous graphic that we had up here, you see we had, we're only taking data every 10 minutes, but you realize that even though we say the beaver is inactive, we know something about the data collection. We know that the beaver is flagged as being active or inactive simply based on where it is physically located. So it's quite possible that it was waking up and it was active inside its little house or its structure. And so that can give some insight into why we have these outliers. This is probably when the beaver was waking up before it transitioned into being in the awake state. Okay, so we have a box plot. Let's say we have our box plot. Good, we got that. And we have a colored scatter plot. And what else can we have? Oh, maybe we would like some confidence intervals. But we need to subset the data in order to do that. And so, again, I have on my script file, I have subsetted the data, so I'm just going to copy these guys in. Maybe I'm going to paste it. Sometimes it takes less time to just retype. Alright, and now what I want to do is I want to create a confidence interval for this. And I'm going to just see if I can remember how to do my confidence intervals. How did I do confidence intervals? They were in here somewhere. There we are. And I want to install packages. You don't need to include that anymore. I changed my mind. I don't care if you include the one that says installed packages, but you do have to include the line that says library. If you include a library I did not use, I'll just install it. Okay, and then we have beaver, but we're not using beaver. We're going to use day, so the beaver's temperature in the day. And the confidence interval for night. There we go. Okay, so we have confidence intervals. Great. What else do we want? Let's see. We have... Okay, I'm going to do a 5-number summary, but I'm going to warn you that it's not really useful. Not useful. Why? The reason why it's not useful is because it's only going to repeat all the same information that we already had in the diagrams. So the reason I'm going to do it is to just remind you how to do the 5-number summaries, is so you know, you already know how to do them, but to remind you that in most projects it would be very useful. And the other reason why it's not very useful is we really want to think of the data as being split on the activity level. So this is just pushing all this together, and the reason why this is problematic is we don't have a whole day's worth of data. If we had 24 hours worth of data, this would be a much more meaningful measurement, If we had something like 36 hours worth of data, then I would recommend that you take a slice of 24 hours worth of data. But in any case, this is going to be skewed because we have started tracing the animal at 9:30 in the morning and we stopped at 2 a.m. So we have a big gap and we don't really know what's happening over the course of an entire 24-hour period. So this is a weakness. This is a problem with this data set, and you really can't fix it. So that's why I don't like a 5-number summary. I would do it if we had an entire period of like when it woke up until it went to sleep again, and then you could say, hey, what's the 5-number summary for its temperature when it's active, or likewise when it's inactive. But we can't do that, and so it's just kind of stupid to do it. Okay, so I don't like this. All right, I can't even think of another thing to do, and so I've only gotten 6 things, and the project requires 7. So at the check-in, I would tell the student, you know, I don't think this is a really good data set, and that's why I wanted to approve your data sets in advance to prevent this kind of thing from happening to you. So there's the 2 things I want to avoid. I want to avoid you having data sets that are too simplistic so that they don't go very far for you, and I don't want you to have data sets that are too overly complex and sink your entire semester. I want this to be a short and sweet, simple project for you. I don't want it to be life-consuming. Okay, so that's why I want you to check in with me about your data sets before you continue. If you have a data set that's very complicated, you can cut back, but if you have a data set that is not robust enough, you can't build it up. So anyway, so the summary points for you are you should use paper. You should keep a file of all your code as you're creating it. So in the case of R, that's an R script. And at check-in time, when you're checking in with your preliminary results, this is what I want. I want you to have your data set, and I want you to have this kind of file. The script file if it's R, or a do file if it's Stata, and if it's SPSS, then it's going to more likely be some kind of typed up notes where you tell me which things you did when, or you could capture the code after the fact. You could capture that PDF like we did in the homework. But in any case, you need to clearly tell me what your results are and how you got them, and then we talk about them and see how to move forward and see if it's enough to make up a presentation. Okay, and then my next video, I will show you how to turn this information into a presentation. Again, remember, it's going to be a weak presentation because the data set was weak. But I will still continue with this as a demonstration piece. I think that's all I wanted to show you for this.